I'm currently involved with aspects of fusion reactors, the third generation nuclear power plants, and on microreactors, which is something we might explore later on. I'm a visiting professor for the Royal Academy of Engineers. I've got a VP role also at Liverpool University. I'm involved with the IMechE as the facilitator for the Northwest and one of the main players in forming a student. I'm quite proud that I actually received the Jan Runemark Award last year for the work I've done with bringing on young engineers. So Camel Laird, they're even older than I am, established in 1828 by John Laird. There's nearly 1,400 ships being constructed in this place. And probably the key element about Camel Laird, it's never been short of innovation. It developed the first all-steel ship for Robert Livingston and the first all-welded ship, and has continued to be very strong in innovation ever since. The site's long and thin. It's getting on for 3/4 of a mile in length. It's 130 acres in area. And as you're looking at the screen, everything towards the right of the picture, and you'll see some dry docks, is to do with ship repair and conversion, and everything towards the left of the dock, or the wet basin as we call it, is where the heavy manufacture goes on. In fact, the large building you're seeing in the near the yellow painted intermediates is one of the biggest construction halls in Europe. Typical turnover, well, last year was 125 million. This year it's probably near 160. We've got typically 850 full-time employees, and we've probably got about 400 additions at the moment as we're working our way through some pretty major projects, which I'll talk about later on. So one of the baseline aspects for us, which is particularly relevant to the nuclear industry, I think, is the fact that we look after quite a few of the Royal Fleet Auxiliaries, the tankers and supply ships for the MOD. But the most important aspect of that is the fact that that accreditation, BS 11000, came into being in 2015. And we were one of the first companies to receive the accreditation for collaborative working. I can't express how important that aspect has been in getting these ships out to a high condition of availability, working within a state of genuine partnership and collaborative working. It's something that, frankly, we've been very bad at within the nuclear sector as a whole. And this is something I think there's a serious lesson to be learned there on how this can be worked and worked successfully. We're located in Birkenhead, and it's certainly one of the areas in the UK that has some pretty serious social challenges. And we see ourselves as being a very important part of the community. We are really here about providing high-value jobs in this area, and have done for the best part of 200 years. At any one time, we have 10% of our people in training, including an apprentice scheme that we're particularly proud of. Frankly, to be a Camel Laird apprentice is a real badge for any young person wanting to go into engineering. We're involved with the local universities. You'll see here I've got the Liverpool John Moores and Liverpool University form the student cars. We have them here regularly, and we're getting increasingly close links with these universities as we want to raise our game and our technology as we work our way through into other markets. So as a company, we're pushing hard for safety. We're the safest shipyard in the UK, but we're nowhere near where we want to be as far as the energy side goes, including nuclear. I mentioned the apprentice training. We're looking at continual investment in the facility. We've just put 6 new cranes in there, and there's other facilities being upgraded as we speak. We have a capacity at the moment of something in excess of 4,000 tons of fabricated steel, and we can double that quite easily. We do have the outline planning permission to be able to expand on that, and to be able to build new facilities as required. A recent project for us was, in fact, to move out these large turbines of 32 8-megawatt turbines, and in fact you can see in the right-hand picture the large intermediates being loaded onto the jack-up rig at our facility in Birkenhead. Those intermediates weigh just under 700 tons apiece. They're 4.5-meter diameter, 65-meter long intermediates. And the crane in the shot there is 1,000 tons. So we're familiar with moving large units safely and efficiently for these big energy projects. You saw the headline at the beginning about from the Wind Energy Network, who are noting the steady falling in strike prices for the offshore wind. And to me, this is something that we as a sector, as the nuclear sector, really need to sit up and take notice of. If you think where they started not that long ago with a strike price up around £150 per megawatt, and here we are now in the North Sea, looking like we're coming through the Hinkley line and going on towards the combined gas. Just shows what a drive for innovation and rapid incorporation of, or imaginative incorporation of commercial arrangements can do. And I think there are things here that we really should be mimicking within the nuclear sector. So just looking at that, well, I do remember, I'm old enough to do that when we were going through the 70s into the 80s, one of the things was to ensure that we were never ever going to end up with multiple types of nuclear power plant, so that we could have a common type throughout the UK. Well, I think we've singularly failed with that, and we seem to have a real catalogue of the nuclear new build. And I said the TBC against Moorside, and of course we've just had the announcement from from Korea. We're obviously looking at SMRs and micro, and in fact the picture there is that the U battery, the 5 megawatt E or 10 megawatt thermal high temperature reactor that U battery are at the moment working up. We're partnering Urenco and others on this project. And there's been some incredible levels of interest being shown in this project from quite a number of overseas governments. Of course, we still have an ability. We're still one of the major centres for fusion. One of the interesting things from our fusion colleagues is they're adamant that what's happened to fission will not happen to fusion, i.e. the capability being thrown away to the point where we're utterly dependent on overseas designs. And of course, decommissioning is still going along in the background. So we've got some pretty big challenges. You're aware that you can read these things just as well as I can say them. Probably the biggest thing that caught us out was the fracturing of the industry. Where we are no longer have a major say in any aspect of the industry itself. There's no doubt the on-site build, installation and commissioning of the systems is a hideously expensive way of doing the job. The scars are pretty deep on my own back from work done in the 70s and 80s, 90s on this, where you have multiple work faces exposed to weather. But perhaps most important of all is that you're having to deal with a temporary workforce working away from home, which has an impact on production efficiency and finance and so on. I won't go on any further. It can be quite depressing. So this was just a picture of one of the plants I was actually directly responsible for. It just really pushes on the whole issue about a stick-build approach and all the challenges that can bring in, whether it's weather, access, temporary workshops, facilities, and temporary power arrangements. Away from home for the people, which is increasingly important. People don't seem to like to work from home away from home as much as they did. Of course, the disruption to the local economies is quite significant. And again, I've got bitter experience of that. And then, of course, transportation and so on. I just thought I'd step into a few examples now of you know, what we do in the shipbuilding side. And this was I thought quite a neat little example where a cable layer, the Nexon Skagerrak, was brought in for a 12.5 meter extension. You can probably just see the yellow circular, horizontal circular field in the middle of this the ship, which is where the cables lay. And this is just about where they wanted to cut the ship in two to insert 12.5 meter long module. The key here was that this project had to be delivered within 80 days. That's 80 days. So the ship was cut. If you look to the right-hand picture, you will see where the ship has been cut in two. And in fact, that's a 500-ton module that has been manufactured. That was manufactured, obviously, ahead of the ship coming in. It's fully outfitted, and it's been seen here being loaded into the dry dock in between the two halves of the vessel. There's the ship leaving on day 76 as a fully commissioned system. It wasn't just the insertion of those modules, it was the complete updating and upgrading of the ship prior to it being exported. So I mentioned, you saw pictures earlier on of the carrier. There were carrier blocks. We were responsible for the Queen Elizabeth and for the Prince of Wales for the delivery of quite a number of modules to make up the flight deck of the aircraft carriers. And you can see the dimensions, typically 40 meters wide by 21 by 15 meters, and they're around the 650 to 850 tons. And there was 15 of those went out of this shipyard. And here you can see some of the manufacturing. These are the subunits. In other words, where on the left-hand picture, there's where the whole deck's worth. It's 40 meters wide, remember, is being laid down. And what you see there is the blocks are actually upside down. The flight deck, for example, is very, very critical in shaping on the carrier. So it was laid upside down, and in the end, all this was turned the correct way up, and we can go up to 240 tons. And then, as you can see on the right-hand picture, we stack them to make up the supersized module. This module is typical of what I would consider, it's a reasonable size to me for what we would be importing into a nuclear plant. And there it is. This is one of the units being brought out of the construction facility, ready for painting. Where you see the big red movers there, that's actually part of the hangar. So this thing was quite a difficult handling project. It's a bit like lifting a dumbbell, you can imagine, with the weight concentrated at either end. But probably significant here is that the tolerancing on the hull is plus or minus 4 millimeters. And obviously it was essential to maintain that geometry whenever it was being moved like this around the facility, or when it was to be transported by sea around to Offsite on the Firth of Forth for assembly. Of course, we weren't just sending empty boxes out. You can see again the dimensions. These are the typical outfit of these units. Pretty well everything that could be fitted into these units at that stage was. If you look to the top right-hand picture, you'll see that the internal lights are in fact live. There's a load of air conditioning units in here. But you'll also notice every surface is protected. Our policy here is that whenever anything leaves us, it goes out fully cleaned and protected and appears as new at the other end. You can see some pretty sizable pipe work going on. That's 300 millimeter copper nickel pipe in that center unit. And just on the bottom right, as a bit of fun, you'll notice we even fit the waste paper bins. There is absolutely no limit at the build end of what you can fit. It's all at the other end, at the receiving end, in terms of the ability to be able to handle it and lift it. I should make the point that all these units actually left either on the tide of the program, this is a 4-year program, or in the final 4 units, they were asked to be delivered early and they were sent out 2 months early. And you can see again the typical handling arrangements that go on here, a series of SPMTs, and we use outside contractors, ALE or Sarans, to do this work. It's a critically important job, so we use people who do this every day. And you can see the picture of that 130-meter long barge being loaded with 5 of these units. Again, you can picture those coming alongside one of the nuclear power plant moles, you know, with these fully equipped, fully commissioned units ready for installation. And there it is on the installation. If you may remember, I talked about the tolerance of plus or minus 4 millimeters there. In fact, on the Prince of Wales, the second ship, they went out without any green, without any cutting or any additional grinding allowances on the outer edges. All the mating faces were pre-prepared and ready for welding. In other words, they landed and welded them. So the tolerance and again and the handling of these was so important. And that was the ship, as we know, floating out. She went out for her for her first trials earlier this year. And I suppose if you talk modules, if you talk about a complete ship, it's probably as near to a full-scale module as you'd ever get, because it's pretty well got everything on there. This is one of the small ferries that we've built, again, completely built. This was done in 15 months. From contract start to finish. And I think most of you are aware that we are involved in the build now of the new polar ship. Some people call it Boating at Boat Face. Formally it's the Sir David Attenborough. But she's quite a large vessel, and she's certainly the most complex non-military vessel that's ever been built. General view is in the world, but certainly in the UK. And you know, the 130 meters long and 24 meters in beam, she's quite substantial. And basically, we've got 34 months to deliver her. I mean, again, you can read these at your leisure, but she's a very advanced ship, incredible level of capability in multiple roles, whether she's in ice or she's in open seas. Whether she's acting as a laboratory or floating laboratory, or as she's supplying the Antarctic bases, you know, with 4,000 tons of cargo. This is basically how we broke her up to, or divided her up for building. You can see effectively these are supersized modules, 10, 20, 30, 40, and so on. Just out of interest, 10 is actually being built and, as we speak on the Tyne by our sister company, A&P Shipbuilding, over on the Tyne. And that's 830 tons of a module. So we started with 20, which is pretty well complete, and we're well on to 30 now. So it's about 3,000 tons of this 5,500 ton steel vessel. Which is then going to incorporate another 5,000 tons of outfit. The ship is very tall. It's 45 meters from the keel to the masthead, so we can't get that through the masthead door. So we will be welding the stern on 10 to 20, as you'd expect. We will slide the ship out of the construction hall. We will then land the 51, the superstructure, fully outfitted, before we send her into the sea. Again, just ideas. These are, I think this is very analogous to what we could be doing in a nuclear structure. She's an ice-hardened ship, so she's very heavily ribbed, and you can see some of the systems in here. She's a civilian ship, so she's plus or minus 6 millimeters on tolerance. It's typically, but we generally work half of that. And what you're looking at here are components that made up 20. And this is a view outside my window. In fact, we've just shifted some of these, more of these today. These are subunits. They weigh about between 80 and 100 tons, being brought from one of the other manufacturing facilities on our site to be brought round for incorporation into the hull of the vessel. And in fact, this picture shows one of the units. This was one of the first pieces to be put down. And in fact, the operation that was going on here was in fact the inverting of the unit from its upside down manufactured piece to, as it's shown now, the right way up. This particular unit was about 130 tons, and we do these inversions on a regular basis. Of course, one of the challenges with this sort of thing is that you have to stress and reinforce the structures to enable them to be handled like this. So the business of maintaining geometry goes on really from day one, from the point of manufacture of the subunits to their rotation, to their installation into the major part of the vessel, and so on. This is another component. This picture was taken a couple of weeks ago, and what you're seeing here is just the first part for the item 40. It's towards the bow of the vessel, and again, it's been suspended. It's just been inverted the right way up, and you'll notice there's some quite interesting compound curves on here. The blue, the tarpaulin on the left, is actually one of the generator sets, one of the Rolls-Royce generator sets. It's ready for installation. And in fact, they'll be going in any time now. If you look at the small diagram above, you look at 30, and you'll see one of the generators outlined in there now. And it's something to think about here, that once installed, that's it. They're in, sealed. So these units go in as fully commissioned systems, and they will not see the light of day again. And if you look, while we're talking about that, you look over to block 20 on that same picture, and you'll see the twin electric units in there, 125 tons, that were installed just in the new year and are sitting there fully encased in marine ply, ready for the final testing. This is a picture of the unit being, of the boat itself being assembled. So it's basically block 20. And as I said, to me, quite a nice size as a unit for going on a power plant. So she's about 30 meters long, 24 meters beam, 15 meters high, and weighs about 2,000 tons. Again, to plus or minus 6 millimeters. And just for completeness, this is the block 10. It's actually, as I say, it's earlier in the year, showing the incredibly complex hull shape and the stiffening steel to keep that shape good, as it will be brought round by barge from the Tyne, about 4 days at sea, to be brought back to the shipyard and then offered up to the main hull. So they were just examples really of what can be done and is being done in advanced module building, and I deliberately went for those ships because they are extraordinarily complex types in their own, and they're being built to very, very tight tolerances. Doesn't mean that you could just jump straight into a nuclear base, because obviously a completely different suite of codes in there and the different materials and so on. But what we're saying is here that this could offer a real benefit and bonus for the UK's nuclear program. A lot of words there. I'm not going to plow through all of them, but what we're saying is there are serious exemplars and costings benefiting the support the off-site build. I think really the nuclear program is pretty well the only sector that hasn't adopted this now, and I've lifted these 2 points where aerospace reckon that by going through their lean processes, and I think you're very aware that certainly large-bodied aircraft they spend an awful lot of time traveling before they're finally assembled as final units. And the classic is in our own Airbus. who are building in the UK, who build the wing sets and undercarriage systems for incorporation in France. And you can see T5, their example, they reckon on 15% coming out. These numbers are considered conservative. In other words, we're talking about potentially 30% savings here. And of course, the UK has a very tight and constricted land approach. I mean, pretty well all the nuclear sites are severely constricted. And again, as I say, the scars are deep on that. We're trying to build big plants at Sellafield. So it's how do you build these units? One of the things we have here is the fact we have access to deep water. And we can build directly and ship directly onto barge, onto sea transport. We're looking at incorporating technologies from all sectors here. We can basically build these very complex structures under the roof. So we've got the quality management systems, we've got the supply chains, all tooled up for that common goal of building a right first time subsystem, if you like, to the highest possible level. We're also aware, of course, what are the challenges, and Cammell Laird has taken the contract on behalf of the Innovate UK to look at how would we build nuclear modules, and we've broken it down, as you can see, into those 3 different sectors, and deliberately people and culture at the start of it, followed by process methods and then technologies and techniques. Certainly with people, we have a system that's grown very large and very unresponsive over the years. There's a very strong, it's not invented here feeling within the nuclear sector. We've got to push the typical win culture that exists in this plant, where we're building ships to time and to budget, and others like that, like automotive and aerospace, and accepting, though, that it's not going to be easy. I put that picture up there because it shows Diane, who's one of our project managers. She turned up for work about 5 weeks ago, expecting a normal day. And 3 hours after starting work, she was in front of a BBC crew being interviewed about a new facility we're building for nuclear. It's what we expect people to do now. We're looking for flexibility. We're looking for people who want to embrace change and accept that that is an exciting place to be, not something to be feared. Certainly in terms of processes, no way are we claiming we have all the answers. And in fact, we've been challenged to update the shipyard and the whole way, the approach to shipbuilding in the UK. Certainly for future military or naval warships, we have to look at far more digitization, far more roboticization, and so on. And these are some of the systems that we know we have to build up on. It's certainly the design for manufacture. We've got to get the development of the different manufacturing processes to a higher, and I've said high MCRL, that's manufacturing capability readiness level, to a point where they can be seriously and successfully introduced into the production facilities. We have to design for assembly, we have to design for commissioning, we have to design for operations, and ultimately design for decommissioning. All these things, I think at best we've nodded at, and I've certainly, again, I'm as guilty as the next man on that one, on projects where the further away it is, the less attention it's got. Afraid it's not an option anymore, because you've got to design it right first time. Because basically, once you start building one of these, you can excuse me, you can no longer introduce serious change without really hitting the program in a bad way. I just thought I'd show you these 2 pictures, really, because the one on the left shows 2 modules coming together. It's actually, again, this was on the polar ship, and you can see what you're looking at is the outside of the hull with the temporary steelwork that's been placed so that the vertical all-important joining welds can be made. Remember that plus or minus 6 millimeters, or as I say, plus or minus 3 millimeters. You've got to get it right first time. You can't change the shape of this. Once it's done, it's done. On the right-hand side, it's just showing a bit of good practice. This is the working face for two modules. And what you see is you may be able to make out the different plates that have been tacked onto the face of that. And they're all the different filling plates that will be fitted after the two modules have come together. And this is just good practice because basically it saves you having to route those small plates out of the stores, down through the ship, and then to the workplace. You literally just grind them off the face and fit them. And this is something that was adopted throughout the aircraft carrier, and it saved an extraordinary amount of time and effort. It's a small thing, but it's these are the sorts of things that come out with experience when it comes to design for modules, design for assembly. So yeah, we've talked about already about just in time, and I'm aware that I'm not going to go on too much longer. The just-in-time procurement is the key. BIM, virtual engineering, augmented reality, arguably the more important of the two, where we need AR for people like these two guys in the middle here. How can we use AR to make his job, his welding job, that much easier and that much more certain? Can we use AR to reduce the number of inspections on this? Can we use AR and its equivalent so that the inspectors, our regulator colleagues and that, can look on any structure at a given time with confidence to get the full history of the not only the raw material, but what's been done to it, what processes have been done to it throughout its life. We've talked about logistics down there. Certainly, we have certainly a good deal of experience in this, but it's something where it's generally only been nodded at, usually after the event. The logistics are extraordinarily important. How we plan to get these large units to the site, moving them on the site, and then ultimately installing. There's always a downside on anything. I mentioned earlier that one thing we'd have to do, particularly with our design teams, is once they've designed it, they've designed it. They have to get their hands off it. They can't keep poking around at the design, because once you start your construction build, that's it. So any serious design changes, it could involve serious surgery. If you can imagine that ship, if you had to change the generator sets out of them, that means cutting your way through several bulkheads to get into there. It can be done, but will cost an awful lot of time and money. You need certainly an awful lot more time on the design and engineering for modules and safe transports, and that includes the manipulation of these. We're talking about possibly between 20 and 25% additional steel here going into a structure simply to ensure that it can be transported safely and delivered safely. And of course, there's a little bit of the eggs in one basket. Don't deny that, you know, that you send these large units to sea and incidents can happen, even though you do as much planning as you can. But again, this is done increasingly, more increasingly the case around the world. And basically, we work on the premise you could send a module to sea by 4 days or 40 days. It frankly doesn't matter. You can read the rest of that. This is what I was mentioning earlier about the manufacturing readiness levels, MCRLs. And what we're about here is about addressing the 7, 8, 9. We have any number of universities and research centers looking at 1, 2, 3, 4, and even into potentially the 5, 6 now with our catapults. But what we see ourselves here is very, very much involved in the 7, 8, 9, and it's about being able to introduce fully developed production systems. And this is again where we're working with Innovate. fully commissioned, fully completed, ready to go into the production halls. Just a very quick picture. We've recently, as a Tier 1 member with the Nuclear AMRC, we've just set up their Birkenhead facility, and we're delighted that they've started with us. It's just over a month since we had the formal opening. And it's interesting that this is a purpose-made facility for us. You'll see the picture on the left. It's about 800 square meters. And it's got a completely different feeling there to where we are in the shipbuilding, but it gives you at least a scale of where we would be wanting to develop those high MCRL systems. And of course, we'd like to look to the future. If you look to the very top right-hand corner of this photograph, you'll see the current shipyard, the Camel Laird, and the main picture, the main part of the picture shows the old Birkenhead docks as they are at the moment. And in fact, in the foreground, you'll see the Mobile building. And this was, in fact, in the vicinity here, there was a tank farm. That's all been cleared and characterized now. And Camel Laird, along with Peel Holdings, is looking to build a state-of-art facility here. To build, ideally, to build large units for the energy sector, and ideally the nuclear sector. And that's just an artist's impression of what we'd like to build. Essentially, it's building what we have at Camel Laird's now as a 21st century version. So you can see deep water access, so you can bring materials in, you can take and export large modules. You can see the large building with the striping on there would be effectively the huge assembly building for assembling the modules, and then the buildings in front and around to build sub-assemblies, to run the logistics, and probably most importantly of all, to run the training, where you would see, I hope, apprentices coming in at one end and PhDs in the other. So we see ourselves in an ideal position for module build. We call this the energy crescent. It's, there's all sorts of words used. You'll notice we encompass within here the Moorside site and Sellafield, and it sweeps all the way around to Wilver, bringing in the major engineering capabilities of Warrington, Manchester and Liverpool, and certainly a lot of the key universities of Manchester, Liverpool, Leeds, Sheffield, and so on. And certainly we saw this as a potential centre for building these large units. And as I said earlier, we're about 16 hours away from Moorside or from Wilver, but we could be, it doesn't matter if it's 40 days, say, to around to Japan. So just finishing now, probably the most important aspect of what we're about here is that we are confident it improves the safety, this is conventional safety, of our people who are working on this. They're people who go home at night, they work with people they know, and they're in a familiar environment, and they're using fixed equipment. We know the quality of that in a controlled environment. Again, a building that's been purpose-made, again, is better, and it's, again, linked with people who understand the procedures. There's less demand for travel and temporary accommodation and infrastructure at the construction site. I can't emphasize that enough, the devastating impact that can have on a local economy. It's not the time of the build, it's not the time when people are tooling up for it, it's the aftermath that's so bad, and it doesn't seem to matter what planning goes into it. There's always a devastating impact on the local economy. We're looking at cost-effective manufacture. This is for bringing in high-value components. I've put the generally nuclear side of it there, but it does go on to other sectors. And we're talking about delivering discrete modules that are complete and ready and commissioned and validated prior to delivery. Again, this is an interesting discussion. It's a point that we're having with our, we've been talking with our regulator colleagues, excuse me, and it's about saying what what validation, how can you validate something from 50, 60, 80 miles away to install it in a plug and play, and it's still okay for operations. We talked about the transportation and offloading. That's a key thing, and it's about reducing risk, and this is risk associated with investment. It's a risk associated with on-site build, and by reducing that concern for the investment community. And you can read the rest of it. We see this as being beneficial to other aspects of the nuclear energy sector. We are in fact talking with people in other major logistical projects with that throughout the UK. We see this as an essential part of the UK's energy mix. And really, that's it. I think I'll probably leave it at that, just with that final slide there, saying that we have worked examples here. We're very proud of what we deliver here. We're even more proud of the quality of what we deliver, and that the costs and the systems are there and there to be seen. And I believe it can be done within the nuclear sector. And I'll leave you with that final image of those 5 carrier blocks being successfully delivered. They're just going across the 3 Graces in Liverpool. And I thank you all for your time.
Great. Thanks a lot, John. Does anyone have any questions? And if so, you can type them in now to the questions box, and John can respond to those. So we'll just give you a minute to do that. And to anyone else who has to head off now, thank you very much for attending, and we will be uploading the recording as well as the slides to the Nuclear Institute website later this afternoon.
Just while they're talking, people are thinking about this, Andrea. As I said, we're not making any claims about originality here at all. In fact, the whole thing we're doing here is about using what already exists. And I'm aware there's a great deal of discussion going on with the big vendors in particular on the new build, on what can be built off-site. So I'm hoping that by looking at these examples, it gives people some level of reassurance of what is possible. And of course, by modern standards, these units are actually quite small. We've got modules in the order of 18, 19, 20,000 tons now being shipped around the world. So I've deliberately kept quite a conservative approach here.
Okay, so I don't think we've got any questions by the look of it, but your contact details will be on the slides, I believe. So if anyone needs to get in contact with you, are you happy for them to send you an email or drop you a line, John?
Yes, of course. Short and sharp, please. That'd be appreciated.
Okay, perfect.
Well, I hope that was of interest. I deliberately punched quite hard because I think we are in that position, and hence the reference to the to the wind energy, the offshore energy, which I think is great. I love competition, and I think the challenge has been put in there now, and it's up to us to grab it and run it up the field. We're not going to sit here just quavering. We've got to take on these other energy sectors and show that we can build to time and budget, as they most certainly have demonstrated.
Great. All right. Thanks a lot, John. Really appreciate that.
All right. Take care.
Okay.
Bye.
Thanks, everyone. Bye.